Almost every machine you've seen works because of just a few core ideas. Number 1. Force. Force is simply a push or a pull. It's what causes objects to accelerate, slow down, change direction, or deform. Without force, nothing moves, bends, or reacts. Machines would just sit there, doing nothing. Every mechanical system ultimately exists to apply force, redirect it, amplify it, or resist it safely. Whether it's a car accelerating, a press stamping metal, or a piston moving inside an engine, force is always the starting point. Number 2. Torque. Torque is the force redirected to cause rotation. It's not just about how hard you push, but where you apply that force. The farther the force is from the pivot point, the greater the turning effect you create. Machines rely on torque to rotate shafts, spin wheels, drive gears, and tighten fasteners. That's why a long wrench makes bolts easier to loosen than a short one. It increases torque without increasing effort. Number 3. Momentum. Momentum is mass in motion. The heavier and faster something moves, the harder it is to stop or change direction. Machines must manage momentum to remain stable, efficient, and safe. Sudden stops create large forces, shocks, and vibrations that can damage components. A spinning flywheel smooths motion by storing momentum and releasing it gradually over time. Number 4. Energy. Energy is the ability to do work. It can take many forms, but it never disappears. It only transforms. Machines exist to convert energy from one form into another in a controlled and useful way. Chemical energy becomes motion. Motion becomes heat. Heat becomes electricity, and sometimes the process runs backward. A compressed spring storing energy is just as real and useful as a spinning flywheel or a charged battery. Number 5. Flow. Flow describes how fluids, gases, or even electricity move through a system. Resistance opposes flow and creates pressure or voltage differences that drive movement. Almost every machine moves something: fuel, air, oil, coolant, or electrons. Fuel flowing through an injector or air passing through a turbine are both examples of controlled flow shaping machine behavior. Number 6. Friction. Friction is the force that resists motion between surfaces in contact. Sometimes friction is a loss that wastes energy, creates heat, and reduces efficiency. Other times, friction is essential for control, stability, and safety. Brakes work because friction exerted from the brake pads convert motion energy into torque that slows the vehicle down, while the rest turns into thermal energy. Tires rely on friction to grip the road and allow steering. Number 7. Heat. Heat is energy transferred due to temperature differences, and it always flows from hot to cold. In machines, heat is often unavoidable and usually unwanted. Too much heat lowers efficiency, changes material properties, and can permanently damage components. That's why engines use cooling systems, electronics use heat sinks, and high-performance machines are carefully thermally managed. Number 8. Stress. Stress is how force is distributed inside a material. It describes the internal response of a part when loads are applied. When the same force is applied over a smaller area, stress increases dramatically. Understanding stress is how engineers decide shapes, thicknesses, and materials to avoid failure. A thin beam bending under weight experiences much higher stress than a thicker beam carrying the same load. When you strip machines down to their core, they're not mysterious or complicated. They're built from the same ideas, repeated again and again. Master these concepts, and machines stop feeling complex. They start feeling predictable. Thank you so much for watching. If you liked the video, please consider subscribing, liking, and sharing this video with others who are interested in simple engineering.